Alright, good day again. My name is Engineer Tolentino, and I'm doing now another discussion of lesson 5 from first order differential equation first order ordinary differential equation course. Okay, this is called solution by substitution. Okay, now let me now define what is a homogeneous equations. If a function f possesses the property that f lambda x, comma lambda y is lambda to the k times f of xy for some real number k, then f is said to have or said to be a homogeneous function of degree k. Let's have an example. Okay, let's have this fxy is x cubed plus y cubed. Now let's verify that this is a homogeneous function of degree 3. Now put f lambda x lambda y is lambda x cubed, substitute there, and then y cubed, substitute there. Now this will become lambda cube x cubed plus lambda cube y cubed, and then you can factor lambda cube times x cubed plus y cubed. And notice that this is repeated, that x cubed plus y cubed, that's the same as what? That's the same as fxy. So this is okay, and notice now that the value of k is what? Comparing the value of k is 3. Therefore, our what? Our degree is 3. Let's have another example. Let's have f of xy. Okay, this is f of xy equals sine y over x plus e. Okay, y over x, okay, is a homogeneous function of degree 0. Okay, so notice that if I put what lambda is what lambda is rather x is lambda x and y is lambda y, this becomes lambda y over lambda x plus e to the lambda y over lambda x. Okay, lambda will cancel out. This is sine y over x plus ey over x. And then notice that this is again repeated there. This is the original one. This is the original function. And then this is the same now as what? Lambda to the 0 times the original function, which is sine of y over x plus e to the y over x. And again, okay, this follows this rule. F lambda x lambda y is lambda to the k f of xy, where in this case k is 0. Okay, let's have another example. Alright, look at this. F of xy is x cubed plus 2y plus 3, verifying that this is not homogeneous. Now if you plug lambda x for x and lambda y for y, you get lambda x cubed plus 2 lambda y plus 3 is lambda cube x cubed plus lambda times 2y plus 3, which you cannot express as the original function. Now here in this case, it's just easy to determine the degree. The degree can be what? Can be found by simply what? By simply adding the exponents of the variables. In this case, what's the degree of x cubed? That is 3. What's the degree of y cubed? That is 3. And what these are 3. Okay, both of these variables has a degree 3. Therefore, this is homogeneous of degree 3. Alright, in the same manner, okay, here in this case, alright, y over x can be written as y raised to the x to the negative 1. Okay, and then you try adding exponents. 1 plus minus 1, that is what? That is the same as 0. Okay, in the same manner that in this y over x is the same. So therefore, the degree of this one, the degree of this function is 0. if we just add 1 and negative 1 there, because both y and x, y over x, are present in both these variables. Now what about this one, x cubed? What's the degree of x cubed? The degree of x cubed is just 3 here. The degree of 2y is just 1. The degree of 3, that's 3, is just 0. So both the degree of x cubed 3 and then 1 and then 0. Therefore, they are not the same. And therefore, f of xy is what? F of xy is not what? F of xy is not homogeneous. Now, to solve this type of differential equation, this is the, alright, a first order dE in the form mxy dx plus nxy dy is 0 is said to be homogeneous if both coefficients of f, m, and n are homogeneous functions of the same degree. So the substitution that we're going to use is either y is vx, then of course dy is v dx plus x dv, or x is vy and dx is v dy plus y dv. Alright, let's have example 1. So our solution, now how do we know that this is what? How do we know that this is homogeneous? What is the degree of x squared? Here, the degree of x squared is what? 2. So the degree here is 2. The degree of y squared is 2. The degree of x squared is what? 2. And then the degree of xy is add what? This is the same as x1y. So the degree is 2. So all elements have what? Degree 2. And therefore, this is homogeneous differential equation and can be solved using what? Using this transformation. Y is vx and dy is v dx plus x dv. So, okay, let's proceed with the computation. Okay, this is the original problem. X squared plus what? X squared plus y squared plus x squared minus xy dy is 0. So plug y is bx now. So you're going to plug y is bx now. Look at this one, y is bx and dy. So your what? Your y is x squared. Rather, your x, this is simply x squared, and then your y squared there is what? Vx squared dx. And then your x squared just becomes x squared, and your xy becomes x times vx. And then transform dy by what? By v dx plus x dv. So this is the transformation, remember, for dy. Okay, that is for dy. And then y is vx. So next is simplify. Okay, so you have what? X squared plus v squared x squared plus and then what? And then now you can multiply this right away. X squared times minus vx minus this is multiplied already. X squared times v, that's vx squared, and negative x squared time, rather this is negative x squared v times another v there, that is negative v squared x squared. Okay, and then this is already multiplied by what? By x dv, x squared times x, that's x cubed, and then what? This one, negative vx squared times x, that's negative vx cubed. Okay, so and then combining, okay, observe that one. Observe that this is common here, that v squared x squared dx there, and the negative v squared x squared there dx. Now this will cancel out. Okay, this will cancel out, and the remaining what? The remaining terms is just x squared and then vx squared. And then of course this will be retained there. And then simplifying further, there will be some elements that you can cancel out here. Okay, factor x squared there. So you have 1 plus n. You have 1 plus b plus x cubed times 1 minus b And then next step is you will have to divide this in order. This can be reduced already to variable separable. To get rid of this term, there should only be there should only be x cubed there. So 1 over x cubed, okay, 1 over x cubed, and then what else are you going to what else are you going to divide by what? By 1 plus 1 times 1 plus b. This is 1 plus b. There. This is 1 plus b. Okay, 1 plus b. So what remains is this one. X squared over x cubed dx plus what? Plus 1 minus b over 1 plus b db is 0. Further simplifying, you get what? Dx over x minus b minus 1 over b plus 1 db is 0. And then finally integrating, okay, you have this dx over x minus b minus 1 db is 0. But your problem now is how to simplify this. This is not automatically integrable. So you can use this one, this property, express the numerator as a function of the what? As a function of the denominator. So by inspection, this is just 1 times b plus 1. This must be the same as the denominator. And then minus 2. Obviously, this is 1 minus 2 is negative 1. That's the same as that. And then finally what? Finally dividing. Okay, if you divide, okay, divide that, divide 1 times b plus 1 over b plus 1, that's just 1, and divide negative 2 over b plus 1, that's negative 2 over b plus 1. So this has been simplified there, and then plug it again, and then this is now integrable. What's the integral of dx over x? That is what? ln of x, and then negative 1, the integral of dv is negative v, plug the negative and negative there, that's plus 2 ln of b plus 1 is equal to what? C. And then you have to return, alright, simplify it first, okay? This is ln of x times, remember this is the same as ln of, okay, this is the same as in ln of, that the ln of b plus 1 is the same as ln of what? V plus 1 squared. Okay, so that gives you there, that gives you product there, product of natural logarithm, because this is a sum. So then simplify this, this becomes ln of x times b plus 1 squared minus b. The only remaining thing to do is return the function. Now remember that b is what? Y over x. Then return it here. So you have to return it here in this equation. B is y over x. So this what happens? ln of x times y over x. What? ln of x times y over x plus 1 squared minus y over x is c. And then further simplifying, okay, this becomes what? Okay, y plus x, just combine this, y plus x over x should have been x squared times that, should have been x squared, and this will cancel out with x there. So that gives you ln of y plus x squared over x minus y over x is c. This is now our final what? Final solution, or the general solution. Next is, let's try to solve x minus y ln of y plus y ln of x dx plus x ln of y minus ln of x dy is 0. At the start, we do not know yet if it is homogeneous or not, so we have to do some simplification. Let's start with, okay, let's start by what? By simplifying first what? This differential equation, because there are ln's here, so we can combine those ln. Alright, factor what? Negative y there in that equation. So you have negative y times ln of y, and then minus ln of x, plus x, ln of y, minus ln of x dy is 0. And then ln of y minus ln of x, ln of y minus ln of x, that's what common here. And then combine that, this is x minus y ln of y over x dx, plus x ln of y over x dy is 0. Now again, that y over x can be written as y x to the negative 1. Now notice we can compute the degree. What is the degree of that y over x? Is 1 plus minus 1. So the degree is what? The degree equals 0. So the degree of this is 0 and the degree of that is 0, and therefore the degree of the first term here is 1, the degree of the next term there is 1, the degree of the next term is 1, because of the presence of what? Because of the presence of the degree of y over x, which is 0, y over x is 0, and therefore this is homogeneous of degree 1. And we can use now the transformation. This is homogeneous differential equation of degree 1, and we can use now this transformation. Y is bx and dy is b dx plus x dv. So, okay, simplify this. Plug y is bx, you have x. Okay, here y, that is negative bx, ln that y is bx over x dx plus x ln that is bx over x there times this one dy, remember, is this one b dx plus x dv. Okay, and then simplify, okay, simplify it. This will be x minus vx ln of v, x cancels out there, plus we have this is vx ln of b, this is simplified there, bx ln of b. Okay, this is already what? This is already distributed there, distributed, so the final answer is bx times ln of b. And then again, this is what? This is distributed there, so you have what? X squared ln of b lang, because this is x times x, so x squared ln of b. Now notice that this one will cancel out there, so what happens is just what? Just this one. Okay, x squared, rather x dx plus x squared ln of b db is 0, and then we have to get rid of the what? Of the, okay, we have to separate this into variable separable, so we just have to divide this by what? By x squared. So dividing by x squared gives you, okay, x dx x dx over x squared plus ln of b dv is 0. Further simplifying and then integrating, we have integral of dx over x plus ln of b dv is 0. Now this portion is integration by parts, so let's have okay, we are expecting a b ln of b there, so let's have what? Let's have the derivative of b ln of b is b times its product of b. What's the derivative of ln of b? Is 1 over b dv plus ln of b times the derivative of b is 1. So integral of the derivative, now integrate both sides now. Integral of the derivative of p ln of b equals integral of dv plus integral of ln of b. Now you notice that I can already what? I can already integrate ln of b, and the integral of ln of b dv is this one, b ln of b minus b plus c. and then you can plug it there already. Okay, so our answer now is len of x. Okay, and then substitute there, b len of b is equal to c. And then returning v is y over x. Return it there, substitute again, ln of x plus y over x, len of y over x minus y over x is equal to c. This is now our general solution of the D. Next. Now, alright, if the differential equation contains this linear elements a1x plus b1y plus c1 dx plus a2x plus b2y plus c2 dy is 0, and if a1 equals a2 equals b1 equals b2 but not necessarily the same as c1 over c2, the associated lines are parallel and the DE is just reducible to this form. We will just present this using an example. Okay, the method of solution is just let D is a2x plus b2y, and of course get dv is a2 dx plus b2 dy, and this transformation will reduce the differential equation into variables separable. So let's have one example. Okay. So let's solve 3x plus 4y plus 1 dx plus 6x plus 8y minus 9 dy is 0. Let's see if this will follow this parallel lines method. So, okay, this is the original problem. Now, the associated lines of the D are parallel because if you divide, this one, divide this and this, 3 and 6 there, divide 3 and 6, divide 4 and 8, and divide 1 and negative 9. So 3 over 6 is the same as 4 over 8, but not the same as 1 over negative 9. So this will follow what? This will follow the method for parallel lines. Okay, so our transformation is let b is 3x plus 4y. We're going to use these first two terms there, and then get dv. dv is 3 dx 3 dx plus 4 dy. And solving for dy here, solve for dy there, of course, transfer 3 dx there, dv minus 3 dx over 4. So you see that we have dv and dy already, and this will be plugged into the original equation. Plug it there, of course, and then plug it there. So okay, so alright, this is our original equation. Okay, then this can be written as what? As 3x plus 4y plus 1 dx plus 2 times 3x plus 4y minus 9 dy is 0. And plug this substitution. Okay, this is what? That is b plus 1, this is b plus 1 dx, and then this is what? 2b, this is 2 times 3x plus 4y, okay, minus what? Minus 9 times your dy is this one, dv minus 3 dx over 4 is 0. And then simplify this by multiplying by 4. Multiply by 4, you have 4 times b plus 1 dx plus 2v minus 9 times dv minus 3 dx is 0. You will have to combine all the dx and the dv's here. Combining all the dx, alright, that's 4 times b plus 1 dx, and then multiply it there, 2b minus 9 times dv, distribute this 2v minus 9 dv and distribute 2v minus 9 to negative 3, you have negative 3 times 2v minus 9 dx. Combine all the all the dx and the dv. So you have to combine that, okay, 4 that's 4b plus 1, 4 times b plus 1, and this combined. So you have what? You have that is 4b plus 4. This is 4b plus 4, that's 4b plus 4, and then this is negative 6 bits there. Negative 3 times negative 9 is positive 27, and then put the x, and then retain this 2v minus 9 dv is 0. And then further simplifying, this is 4b minus 6b is negative 2v, and 4 plus 7 is 31, plus 2v minus 9 dv is 0. Notice that this is already variable separable. Okay, the next step is just divide both sides by negative 2v plus 31. Okay, and then integrate. Now, before integrating, you see that what? You see that this is not integrable right away, this term there. So what you do is express the numerator as a function of the denominator. So in this case, remember your 2v minus what? Your 2v minus 9, okay, by inspection is just the same as negative of the denominator. It's negative 2v plus 31, and then minus 9, plus you just have to balance. Now you multiply negative 31 there, so you add 31 to balance that denominator. Okay, and then divide. If you divide this and this, you have what? You have negative 1, and then you divide 22 over negative 2v plus 31, and then factor negative 1, that is 1 plus 22 over what? Just this is multiplied by negative 1, 2v minus 31. So you see, we already have this. Again, this is already integrable there. So the next step is just plug it there in this equation. So you see that, okay, this is just plugged there. So what remains is this one, okay, differential equation. And then we can integrate. The integral is of course what? X minus what? B, and then minus, if you let u is 2v minus 31, that is du is 2 dv. So you just have to divide 22 by 2. That's why you have negative 11 there. Ln of what? 2v minus 31. And the next step is to plug, okay, to plug the substitution. You see that we are going to what? Return here that b is 3x plus 4y there, and plug it in this final equation. So you have what? You have x minus 3x plus 4y minus 11 times 2 times 3x plus 4y minus 31 is 0. Further simplifying, this is x minus 3x is negative 2x minus 4y minus 11 multiplied by 6x plus 8y minus 31 is 0. So this is our what? Okay, this is our final answer. Okay, so this is our final answer there. So it's there, our final answer. Now here, we just multiplied this by what? By negative 1. So you see this should be 2x plus 4y plus 11, 6x plus 8y minus. This is what? Let's call that C1, where our C, okay, our negative C is just equal to C1. Okay, because this is multiplied by, this is already negative C, which is another arbitrary constant, but they are the same still arbitrary constant. Alright, next is another example. Okay, solve what? Solve x plus 2y minus 1 dx plus 3x plus 6y dy is 0. Now, of course, how do we know that this is what? This is parallel. So just have to divide this 1, okay, okay, that is 1 over 3. So 1 over 3, is that the same as what? Is that the same as 2 over 6? Of course, that's the same. And is that not equal to what? It's not equal to negative 1 over 0. So this follows what? The rule of what? The rule of that we had discussed before. So this is still what? This is still homogeneous. So we'll have to use the transformation of v is x plus 2y, dv is dx plus 2 dy, and solving for dx is dv minus 2 dy. So this is our original equation, and then simplifying x plus 2y minus 1 dx plus 3 times x plus 2y dy is 0. And then you have what? Okay, v minus 1, okay, times what? Plug dx there, that is dv minus 2 dy plus 3v dy is 0. And then combining all the variables again, distributing this, v minus 1 times dv, okay, and then v minus 1 times negative 2, okay, that is v minus 1 dv times, okay, negative 2 times v minus 1 dy plus 3v dy is 0. And then you have what? Combining the dv's and the dy's, you have v minus 1 there, and then this, okay, and then you have to combine what? Combine all the dy's and the dv's. So this is negative 2v and then plus 2 multiply there, and then plus 3v. This is already what? This is already combined, this one and this one. And then, okay, and then finally simplifying, okay, this is just v minus 1 dv, and of course combining negative 2v and 3v there, that gives you v and then just plus 2. And then this is just variable separable already. You see that you can divide both sides by v plus 2 there, okay, in order for just for dy to remain there. And this is your problem again, okay, because you have to integrate, okay, you have to integrate this. So what we do is express v1 minus over v plus 2, express the numerator as a function of the denominator. So by inspection, this is just what? This is just 1 times v plus 2, and then to balance is negative 3. This 1 times 2 times negative 3 is the same as negative 1. And then finally dividing, this divided by this is just 1, and this divided by this is negative 3 over what? V plus 2. And then, okay, there. And then finally integrating, that's 1 minus 3 over v plus 2 dv plus dy is 0. Finally integrating, we have v minus 3 ln of v plus 2 plus y is 0. And then returning the variable, you have to return here that b is x plus 2y. You have what? So return, use this again, okay, this transformation there. So this v and this v will be replaced by x plus 2y. So you have what? X plus 2y minus 3 ln of x plus 2y plus 2 plus y c. And then finally simplifying, that is just x, combine this 2y and y there, that's 3y, and then this is your final answer now. X plus 3y minus 3 ln of x plus 2y plus 2 is c. Okay, next. When we have what? Intersecting lines now. Before it used to be what? Parallel lines. Now, if the lines do not intersect, then this should be the condition. A1 over A2 is not the same as B1 over B2. And the associated lines are intersecting, and the DE is still reducible to homogeneous DE. Okay? Now this is the method of solution. Okay, you will have to what? You will have to solve these two equations simultaneously in order for you to get the intersection. You will have to equate this to 0 and that to 0, okay, for you to have two lines, and then do the transformation of variables. Let's have an example. So here it's what? It's 2x plus 3y minus 8 dx plus 3x plus 4y minus 11 dy is 0. So, alright, equate this to 0. Alright, notice that if you divide 2 and 3, and then here 3 and 4, 2/3 is not the same as 3, 4, and this is intersecting. So the next step that we have to do is to find the point of intersection. So you have to solve these two lines simultaneously. Okay, we can use Kramer's rule. Okay, so we can use a Kramer's rule. Okay, we have what? We just have x is, okay, x is, the denominator is 2, 3, and 3, 4, and then transfer the 8 there to the right, 11 to the right there. Your x is 8, 11, and then 3, 4. This is Kramer's rule. Okay, you're looking for x, and then you have 32 minus 33 over 8 minus 9. That's 1. And then you solve for y. Okay, put 8, 11 here in the y column, and then this is 22 minus 24 over 8 minus 9 is 2. So the point of intersection is 1, 2. So our transformation now, okay, this is the point of intersection, then h is 1 and k is 2. Transformation now will give you what? Will give you x is a plus 1, y is b plus 2, and dx is dA, dy is dB. This transformation will get rid of the constants. So this is our original equation there. Substitute the transformation now. 2 times a plus 1 plus 3 times b plus 2 minus 8, and then this is already dA, plus 3 times a plus 1 plus 4 times b plus 2 minus 11 dB is 0. And then notice that this is 2a plus 2 plus 3b, 3 times 2 is 6, minus 8 dA. This is 3a, that is 3a, then this is 3 plus 4b, and then plus 8, and then minus 11 dB is 0. And then further simplifying, notice that this is 2a plus 3b, this is 2 plus 6 is 8 minus 8, that's 0. 3a plus 4b, that is 3 plus 8 minus 11 is 0. Actually, even if you do not what? If you do not substitute there, the objective of finding the intersection is for you to get rid of just the constants in this differential equation. So what happens is this will just become a homogeneous differential equation of the first degree. First degree, first degree, first degree, first degree. So we will do the transformation, okay, as what we have done before. Let B is BA and DB is BDA plus ADB. And then return, okay, and then what? And then plug it there. Okay, plug it there, these two values. You have what? You have 2a plus 3, this is VA, DA, plus 3a, 4b is 4BA times BDA plus ADB is 0. And then simplifying, okay, 2a plus 3BA TA, this is 3, okay, just multiply it right away. 3a BDA, okay, and then that is 4b times b, that's 4b squared a dA, and then multiply this again, 3a times a, that's 3a squared, and then 4ba times a, that's 4ba squared, and then what? Insert dV equals 0. You have to combine all the dAs, okay, combining all these what? Combining all these dAs there, So you get what? Okay, this is 2a, just 2a, and then that's 3ba, and then 3ba, that's 6ba, and then just what? 4b squared aba plus, this is just retained, 3a squared plus 4ba squared db is 0. And then you can factor a, that gives you what? 1 plus 3b plus 2b squared dA, factor a squared there, a squared times 3 plus 4b db is 0. And then finally, okay, finally dividing by what? Dividing this, okay, we are going to divide this in order for you to get rid of what? In order for you to get rid of the I mean to make it variable separable, divide this by a squared and what? And 2b squared, 2b squared plus what? 2b squared plus 3v plus 1, 3v plus 1. So this gives you the differential equation. Further simplifying, that's integral of 2a over a squared dA of 4b plus 3, 2b squared plus what? 3b plus 1 db is 0. Integrating, okay, 2, simplifying, that's dA over a plus 4b, integral of 4b over 3, 2b squared plus 3b plus 1 db is 0. Now you notice that that your u is 2v squared plus 3v plus 1. Okay, and the derivative is just 4b plus 3, so obviously this is an ln integral only. So this is twice ln of a plus ln of 2b squared plus 3b plus 1 is c, and then we can combine. Alright, simplify again, that is ln of a squared plus ln of 2b squared plus 3b plus 1 is c. Combine using the properties of logarithm, we have what? Ln of a squared, 2b squared plus 3b plus 1 is c. And then, okay, this is getting rid of the c. Okay, you notice that this is the same as just okay, let me call that c1 because this becomes e to the c when you get rid of the ln, where our e to the c is just equal to c1. Then plugging b over a, let's return here. Remember here our b is what? Our b is b over a. You have to return to the original variable, that's b over a. So this is 2 times b over a squared plus 3b over a plus 1 is c. Simplifying again, that's 2b squared plus 3ab plus a squared is c. Of course, this is c1 and this is c1. And then return, you will have to return. Okay, notice that in here your a is what? Your a equals what? Your a equals x minus 1, and your b is equal to what? Your b is equal to y minus 2. So return it there, and you will have our what? Then you will have our final solution. 2 times y minus 2 squared plus 3 times x minus 1 times y minus 2 plus x minus 1 squared is c. Okay, that ends the solution. Okay, next, there are some equations which can be which the substitution can be subjected by the equation. Now, when the D is not homogeneous, equation is not associated with either parallel or intersecting lines, the solution might still be substitution of variables as suggested by the equation. Let's have one example like this. This is neither homogeneous or neither linear. Okay. Now, prob now a possible substitution is this one, because this is the complicated term. Let b is square root of x plus y, then b squared is x plus y. Take the derivative, 2b dv is dx plus dy, and solve for dy. dy is 2b dv minus dx. And then simplify this, dy is square root of x plus y dx. Okay, dy is square root of x plus y dx. And then what? Plug it there, dy there. And then of course this is what? This is v. So what happens is you have what? 2b dv. Alright, this is 2b dv equals b dx. And then combine. Okay, 2b dv minus dx minus b dx is 0. And then combine the dx. You have what? You have 2b dv minus b plus 1. Okay, this is combined there. And then of course divide this by what? Divide this by this is to be divided in order for you to reduce it to variable separable by 1 over b plus 1. So okay. Now this is again your problem. You will have to express the numerator in terms of the denominator. 2b over b plus 1, that is what? That is twice the denominator, b plus 1, and then minus 2. Alright, that is 2 minus 2 is 0. And then divide this and this. This is 2 times 1 minus 1 over b plus 1. And plug it there. Okay, 2 times 1 minus 1 over b plus 1 dv minus integral of dx is 0. And then integrate, that's 2b minus ln of b plus 1 minus x equals c. And then return what? Return the original variable. You have to come back here. Okay, use this again. Okay, and then plug it in the v's here. And then you get 2 times square root of what? Square root of x plus y minus ln of square root of x plus y plus 1 minus x is c. And finally, your differential equation, rather your general solution is what? Is given by this what? 2 square root of x plus y minus 2 ln of square root of x plus y plus 1 minus x is c. Alright, this concludes my discussion for this topic, substitution. Thank you and good day.